All students who have joined, kindly inform to your rest of the classmates and ask them to join as soon as possible. Let us check how many participants we have. So until rest of the people are joining, I would like to know how was the experience with the previous class, the first class which we have taken yesterday. If anybody would like to share their experience with the previous class, what are the things which you loved about the class? What are the things which you want to improve about the class? So I'm expecting people to share their experience. I really don't understand why I have to say everything with the name. Why you people don't take initiative? Don't worry. If you are going to give some bad feedback, or if you want to say something which we want to improve, then it's not going to affect your career. It's not going to affect your marks within this subject. Okay, so don't worry about it. Don't only type in the chat box. Speak openly. The people who understands Hindi, I would like to say, khul ke baat karo. Don't worry about anything. Share the feedback of the class. Is there anything which you want me to improve? Seems great. It was good. It was cool, sir. Let's observe some lectures before giving the. Okay, that's fine. Fine. So, is there anybody who would like to say something, sir? Add this much more so that we can be little more comfortable. Fine, that's okay. So let's start today's class. So let's have a quick brush up what we have discussed till the previous classes, till the previous class, in fact. Okay. This is not definitely the subject. This I was giving just as the example. Okay. So we have discussed that whatever the programming language you are talking about, either it is C language or anything else, whatever the programming language you are talking about, that is executed. The programs written in that language are compiled and executed by compiler. And obviously, the basic step which is performed by compiler is to check whether there is an error or not. All right. So I told you that the machine which checks that whether there is an error or not, that is called automata. And the first step to go for checking out whether there is an error or not, so that first step is basically the pattern matching. Right, pattern matching is something first which we have to take care for. All right, and the tool which performs this pattern matching is actually the automata. Right, that's what we have discussed already. Fine. Next is types of automata, which I have told you the names only. We have discussed that there is finite automata. Inside that there are two different variations. All right, like that other automatas are there with the same two different kind of variations. And then we have discussed how finite automata works. We have discussed that it is a it has a it is basically a five tuple tool, and within this the tuples we were discussing. Okay, so what were the tuples we have discussed? The five tuples was: one was initial state, one was set of states, one was set of final states, one is sigma. So I told you that this is the symbol for sigma, and delta, and this is the symbol for delta, which is the mapping function. All right, maps every state with respect to the input symbol. Although out of these symbols we have understood just two three tuples only. All right, those two three tuples were: first one was the input symbol.
Sir, are you pressing in the screen?
Sir, screen is not visible.
Is it visible to everyone?
Yes, sir.
Yes, sir.
Perfect.
Yes, sir.
Yes, sir.
Perfect. 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 Yeah.
Yes,
So
sir.
that's what we have done. We, out of those five tuples, basically we have discussed that what is this input symbol is all about. All right, we have done with this particular thing, that what this symbol is all about. And then we have discussed how automata responds for the exception and rejection with respect to the strings. All right, so these are the things which we have covered yesterday. Now we are going to go further. So these were the things which we have discussed. Okay, we have discussed that there are three types of states. We have the initial state. Initial state is something which with automata starts. There is a non-final state and there is a final state. Okay, one very important thing which I have told you, that the name of state really doesn't matter. What matters is the notation what you are using for it. So if this is the notation with either q0, q1 or any suffix, then this is definitely going to be the initial state. Doesn't matter what is the name of the state, even it can be qa or qb also. Okay, even if it is the combination of symbols qab, but if it is written like this, that means definitely you can say that it is initial state. Right, apart from this we have final state with this notation, and we have any non-final state with, which is not also initial. Right, that state is being represented by this single circle. Okay, and how automata finds out that whether the string is accepted or rejected, how it tells you whether it is accepted or rejected. So it tells you with the fact that if your string ends up on a non-final state, if it ends up on the non-final state, then you can say that it is rejected, or if it is ended up with any of the final state, then you can say it is accepted. If your automata is accepting a particular string, that means the pattern of that string matches. That pattern matching is perfect. And if it is not accepting or it is rejecting, that means that pattern matching is not there. Your string didn't match the pattern of the automata. All right, so this is what we have discussed in the last lecture. I have given the summary of the last lecture. The reason being, because if somebody might have come little late into the lecture of the last lecture, or if somebody have not attended the lecture, he can get a rough idea that what we are talking about and what we are going to talk about in today's lecture. Okay, although it's not a good practice and we will not be able to continue this practice further, because it's not a good practice to leave the classes. Okay, in fact, these classes will be very important to you, not only with respect to your exams. Obviously with respect to your exams they will be important, because the questions what I will be sharing in the class, they may come directly into the exams. Okay, and if you will not be attending the classes, so it's like what I have seen in the past 8 to 10 years in my teaching pattern, that generally the people who are attending the classes regularly, they are able to write their exam paper very easily. And generally if the people who have not attended my classes, they like any internet doesn't help them. The questions, the type of questions which I usually throw in the papers, exam papers. Okay, so it's good to attend the class, and I'll try to keep it as crispy and as interesting as possible with your sincere help. All right, so let's start today's content. What we are going to discuss, I will do just a little change. Only the introductory PPT. Actually yesterday I did not have my pen tablet with me, so only the introductory PPT I am deleting these slides. I will make these slides Now onwards, like whatever the slides we will be creating, those slides I will share with you every day on the Telegram group, so that you can access them whenever and however you like. Okay, fine. So let's start today's content. So the states now we know. Okay, so out of those five tuples, how many tuples we are aware with? We are aware with the states, and with respect to states, there were three different types of tuples available in the automata. One was initial state, and as I have told you that the purpose of initial state is whenever automata is starting, so that will then it will start with this initial state. All right. One was the set of states. So this includes, in fact, you can think of in this way, that basically it has two different types of states, category of states. One is initial, one is which is not the initial state, rest of the set of states. And out of these two categories, one is non-final and one is final. This is a set and this is also a set. That means we can have multiple non-final states and we can have multiple final states, right? So we had five tuples. What are those five tuples? We had sigma. Okay, we had q0, we had q, we had qf, and we had delta. So out of which how many we have covered? We have covered this one, we have covered this one. This is known by q0 generally. Okay, but as I've told you, if you want, you can change this symbol as well. Okay, then we have covered this one also. So what is this? This is q, set of non-final states. Okay, and one is qf. So what is qf? Set of final states. It's called to be qf. This is sometimes called as f also, right? Different books have different notations. So some of the books have this notation qf, some of the books have this notation f. In your exam you can use any one of them. I will not deduct marks. Okay, whatever you like. Now we are going to talk about this delta. Okay, so this is called, either you can say mapping function, or this is called transition function. This is called, the perfect name for this one is the transition function. Okay, now let me tell you what this transition function is all about. The general form of this transition function is like qi with respect to some input symbol from sigma, and as the output what you will get some other qj. Okay, where qi and qj both belongs to set of states. If you check carefully, you know this f, which is this qf, we will use only one notation, right? So let us remove this notation, let us use this f. So this f is nothing but the subset of q only, because set of states contains everything. In set of states we will mark everything, q0, rest of the non-final states, rest of the final states, everything we will be marking up. All right, so it may belongs to either q or f, any one of them. Okay, now what is the meaning of this notation? Let me explain this thing with the help of a diagram. Suppose we have this particular state whose name is q1. Okay, now on this state, if I get one symbol a, then I am supposed to go on some state q2. Now it really doesn't matter whether this state is a final state or it is not a final state. It really doesn't matter to me, as if now at least. Okay, similarly for this one. So what we are doing, this is what the transition function, the notation what I have written over there, that delta some qi with respect to some sigma, we have qj. So if you map this diagram with this notation, what you can get, you can easily find out that here this qi is what? Q1. All right, this sigma is what? A. And finally, what we are getting? Q2. So what we can think about it, that on state Q1, if symbol A is detected, then I will move to state Q2. Shall I write this statement? Let me write it. On state Q1, if symbol A is detected, then machine will move to the state Q2. This is the literal meaning of this transition function. And I hope this is now quite clear to everyone. All right. Now, with respect to this, if anybody is having any kind of doubt, please ask your query. As I told you before also, don't wait for me to finish the lecture. Don't think like that at the end you will be asking queries, or I will say that don't interrupt in between. Ask your queries at the end. Ask it right now if you have the query.
Once again, sir, please.
What once again?
The statement.
This statement. You can read it. Come on, read this one. And if you are not getting it, then ask me.
Yeah, I can read it. On state Q1, if symbol A is detected, then the machine will move to the state Q2. Yeah, I didn't
All
get
right.
it. That's why, sir.
Okay, fine. So basically, let me repeat this thing. On state, let us imagine, see how you came to Q1, that really doesn't matter as if now. Okay, because we are just understanding transition. Now, first, let me ask you, what is your name, dear?
David,
Which one?
David.
David. Okay, David. First, you tell me what is the meaning of transition? Do you understand the meaning of transition? What is the meaning of transition?
Transition means when it transforms from Q1 to Q2, it is a transition, right?
That's it. That's what the point.
Yeah.
So now what this is? This is transition function, right? That's what the name what I've suggested for this transition
Okay.
function. Now, when you are transiting from one place to another place, right? That means what has to be there? There has to be some source
Yeah, and there
and
is some
there has to be
destination.
some destination, right? For
Okay.
example, your source is whatever the your country. I'm imagining that if it is Syria, then your source is Syria and your destination is
India.
what? India,
India.
right? That's what we are doing here. Now, in order to come from source to, like, as I have imagined that it is Syria, don't consider the spellings right now, okay, and destination is India. All right. Now, what is the way, like, what is the medium of communication here? How you came from Syria to India?
By flight.
By flight. Okay. So what you can say, by flight. So what is the medium of communication? The medium of communication was flight. The simple relation is there. You just check this up. What is the source? Here the source was Q1. What is the destination?
India.
Destination is Q2. Now we are talking with respect to our automata. Okay.
Yeah. Okay.
Now, okay. And what is the medium of communication? The symbol A.
Okay.
Have you got the
Symbol
point?
is represent flight, right?
That's it. Symbol A is
Okay.
representing flight. So it is representing the medium of communication. In other more proper words, you can say that it is the reason for communication.
Okay. I got it.
Reason
Thanks,
for
sir.
communication, right? All right. Are you now quite clear with this? Fine.
Yes,
Anybody
sir. Thank
else?
you so much.
Okay, perfect, perfect. Anybody else is having doubts in this? Because this is something really important. Let me tell you guys, if you'll not be able to understand this, then this whole subject you can never understand. Because on in every lecture, at least 10 to 20 times I will be using this particular notation, and not only with respect to finite automata, rather with respect to Turing machine, with respect to push down automata, with respect to each and every machine inside this. So right now, even if you ask me 100 questions, I will not mind, no problem. But after taking this lecture, if you will not be comfortable, or if you will not be able to uh, do this thing, then it will be difficult for you and for me also. So I am just leaving you for 30 more seconds with this particular diagram, with this particular discussion. All right, you can see these images, and still if you have some questions, think for 30 seconds, check by yourself, find yourself whether you have some doubt or not. If you have any doubt, you can ask me right now, no issues. Take 30 seconds and just study all that, all this thing in yourself, by yourself.
Hello, sir. Question, sir.
Hello, sir.
Hanji, yes.
Q2 is the final state or is it non-final state?
It can be anything, that depends on the string, and that depends on the machine. Like the example which I have quoted you, this is not the actual automata, right? This I'm telling you just about the transition function, not about the complete automata. So let me repeat this one thing. Although I have said this thing already, okay, so I told you that qi or qj here, that means source and the destination, can be either non-final or final. Both things are possible. When it is final, when it is non-final, that we will discuss when we will be making some questions based on this concept.
So, sir, can we make a double circle like Q2?
Why not? But depends on the nature of the state. It's like we can have double circle, we can have single circle, but it varies from question to question. It's like the type of string which has been given to you, that will decide that whether q1 or q2 should be single circled or double circled. But it can be both. Any one of them can be placed.
Okay,
over
sir.
there.
Thank you.
Okay. Yeah. Anybody else would like to ask? Still, you have the time. Please make sure to ask your questions if you have any kind of single doubt. Even if you have small doubts, the people who understands Hindi, I would like to say, अगर एक 3 का बराबर भी छोटा सा डाउट है, तो खुल के मुझसे अभी सवाल करो. लेकिन अगर आप अभी सवाल नहीं करोगे तो फिर मैं सवाल करूंगा, एंड देन अगर आप आंसर नहीं करोगे तो फिर वो दिक्कत वाली बात है. The people who understands English, I would like to say, ask all your questions right now. But if you're not asking questions now, that means you are clear. Then I will be asking questions to you during the
Sir,
class.
please.
And at that point of time, if you will not answer, that is a problem.
Sir,
Yes. Yes.
according to sigma and A, what are they in here?
Hmm. I I didn't get your point. What are you saying?
Sigma and A in Q1 and Q2, what are they? They will be given.
Sigma is set of input symbols. Sigma is set of input symbols. For example, have you taken yesterday's lecture?
Yeah, of course, sir. I remember the sigma. Yeah.
Yeah. So as I told you, that sigma can be A or B or 0 or 1 or any such kind of symbol. So sigma is the set of input symbols, as I've told you. Okay. And Q1, Q2 I have already said in the lecture.
Yeah. Okay, sir. Thank you.
Okay. Anything else?
Hello, sir.
Anybody would like
Hello,
to
sir.
ask anything else?
Hello, sir. I didn't attend yesterday's class, so I don't know why this state is used for. So can you? Yes,
Fine.
sir.
You can access the YouTube channel. By today, I will upload the recordings of yesterday's lecture. Okay. So I will upload
but-
those recordings and you
but-
can check them.
Okay, but I don't know for what this state is used for.
Ask your question little loud.
Okay, sir. I mean, I understand these cases from Q1 to
Dear,
Q2,
stay,
but I
sit close to the speaker and then ask your question loudly. You are not properly audible here.
okay, sir. I mean, I didn't attend yesterday's class, so I don't know for what purpose these states are used, but I can understand the transition from Q1 to Q2 and also.
Fine. What I will do, first of all, this should not be repeated. Let me tell you. In yesterday's class also I said, and again I'm repeating this thing, that do not miss the classes at all. Make sure to attend the classes regularly and attentively. Otherwise, there will be problem in the subject and you will not be able to clear this subject without taking classes. Generally, generally this subject is supposed to be really tough, but don't worry, I'll make sure that it will not be tough for you. You will understand everything very easily, very coolly and calmly. But for that, you have to take classes. One thing, as if now, just for the first class, what I will do is I will keep last 5 minutes in the class to repeat everything what I have told you in the yesterday's class. Okay,
Okay, sir.
sir, you are scaring us. Ryan, you are scared of what, Ryan? संग्राम रुका, सर हम क्या पढ़ रहे हैं? ऑटोमेटा पढ़ रहे हो बेटा, और बीटेक कर रहे हो आप? ऑफ कोर्स यू आर इनटू द टॉपिक्स. और आपको क्या लगता है मैं कुछ और पढ़ाऊंगा टॉपिक के टाइम पे? Fine. So let's carry on. Since no more questions are there, so let's start further. Okay. Now what we will do? Now we are going to create our first automata. Okay. So how the question may come to you? Let me write that professional language. Okay. So question may come like this. One statement can be written. Design a finite automata. Design an FA. Okay. Design a FA or finite automata for the language which accepts, which contains a string A, or you can say which contain only one string A. Okay, so that's our first question which we have to cover. We have to design a finite automata for a language. That language accepts only one string, that is A. Okay, which accepts only one string. That means the only symbol A should be accepted, rest everything should be rejected. Okay, make sure that you have to understand both the meanings. Okay, so only A would be accepted, that to single A, not multiple A, and rest everything would be rejected. Fine. Now let us design a automata for this. Okay, fine. So designing automata does mean defining the 5 tuples. Okay, designing automata does mean defining the 5 tuples. What is supposed to be the first tuple? One is sigma, one is q0, which is initial state, one is q, one is f, and one is delta. So if whenever we are saying that we have to design the automata, that means we actually have to define 5 things. So let us start defining this. For sigma, you don't have to give any effort. What is the reason? Because sigma is already given inside the language. It has been told you in the question itself that it accepts only A. Okay, that means what is sigma here? A. Clear? So one tuple we have done with. Now this has to be one initial state. Generally it is also fixed. So q0 is supposed to be the initial state. Whenever I say q0 is initial state, that means what? Now it should start like this. Okay, whenever I say this, it means it should start like this. Or let's forget about the tuples. First let us understand the machine, how we will design the machine. So first initial state will be what? q0. Okay, now suppose if user gives me a symbol called a, okay, then now everybody should reply me. I should accept it or reject it?
Accept.
Accept.
Accept, sir.
Accept.
Perfect. So everybody believes that if I get one a, then I am supposed to accept it. All right, fine. Now we have discussed that how to accept something. We have discussed the rule of exception and rejection. And what was that rule? If you want to accept a string, then you have to leave that string onto one of the final state. Am I right? Is that clear to everyone?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Then I should leave it to one of the final state. That means now from this place, I am supposed to go to another state. This state can be named as Q1, Q2, QF, QA, QB, whatever is your choice. Okay. But this state should be a final state. And what was the symbol which you were accepting? You were accepting
A.
A. All right. So what I'm supposed to write here? A. Is that clear?
Yes, sir.
Yes, sir.
Yes, sir.
Is this automata diagram clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Fine. So
Yes,
once
sir.
you have
It's clear, sir.
sure. Ask your question. Who had doubt? I'm waiting for your question. Somebody was saying, excuse me, sir. Waiting for you. Don't know what happened. So since this is clear to everyone, this diagram is clear to everyone. So let's move on to its tuples. Now, if you see this diagram, okay. Now, what is sigma? As I've told you, A. What is initial state? Q0. What is Q? Can somebody tell me what are the set of states? How many states we have used?
Non-final state.
Non-final state.
No. Q, I told you, no, that F is also the subset of
True,
Zero.
sir.
There is no non-final state, sir.
So in all states are the part of Q, not only the non-final states, right? So how many states I should write in Q?
1.
Why
True,
one?
sir.
I told you all the states. All the states, what you are using into this diagram, they are the part of Q only. So F is also the subset of Q. What three states will be there? Tell me the name.
Q naught.
Q naught
Initial
is one.
state.
Whatever it is,
Non-final state and final state.
either initial or final or non-final, doesn't matter. Here I have to enter each and every state. Is that clear to everyone?
Yes, sir.
Whatever the number of states you have used into the diagram, you have to enter here. So how many states are there? Can somebody tell me?
2.
Two states, sir.
Q0 and Q1.
Exactly. Only two states are there. Somebody was saying three, somebody was saying final, non-final. You don't have to classify whether it is final, non-final, and where the one who was saying three, where are three states? Only two states are there. Q0 and rest one is Q1. So there we have defined the tuple Q. Okay. Now it's time to define the tuple F. Tuple F contains what? Set of final states only. Now you have to classify which one is final, which one is not final. So can somebody tell me
1.
how many final states
Yes,
we
sir.
have here?
1.
One, sir.
There's only one final state. Okay. And what is the name of that final state?
Q1.
Q1. I am having only two or three voices. What happened to others? Be attentive. Don't only type in the chat box. Keep on interacting with me. Okay.
We are
So
here, sir. We are here.
yeah, good. Everybody, I'm saying this message to everyone. Listen the things properly and reply the things properly also. You know, when you people are sitting there in front of me in the offline classes, then your facial expressions gives me the energy to teach with more enthusiasm. But as I've told you yesterday, that in these online classes, your voice has to represent your facial expressions. And that's the thing which will give me energy to teach you better and teach you more. All right. So please make sure to be attentive with your voice. Reply fast, reply quick, be attentive. Okay. So what is my final state? Only Q1. So my F goes for Q1. Now it's time for my delta. Okay. Now here I'm writing the delta. So how to write delta? Can somebody tell me how to write delta for this diagram?
Delta Q naught comma A is equal to Q1.
Good. So delta Q naught comma A leads to Q1. That's it. So there I have completed my first automata for this particular language. Now I'm inviting everybody who first look at this question properly, look at this diagram properly, look at everything properly, and if anybody finds out any of the problem in this, kindly reply. Ask your doubt.
Excuse me, sir. Are you
Yeah,
presenting
sure.
your screen?
Uh, I am. I am presenting my screen. If you are not getting it, there may be some network issue at your end. So you can try once to do this. Disconnect yourself and then reconnect again. You may get my screen. Yeah. Any questions from your side?
Sir,
Hanji.
if we have two strings like A and B, that means we will have two final states.
We will discuss plenty of such questions. So not only two
Okay, okay, sir.
strings, I will discuss at least 50 to 60 questions, different types of questions with respect to this. So don't worry about it. In fact, I will keep on discussing the question. In fact, I'll keep on creating new questions until unless each one of you does not understand that how to create an automata for a random string, whatever is given to you. Not only for a string, rather for a language. Don't worry about it. So as of now, let's be stick to this question. If anybody is finding out some problem in this question, then ask me. Don't worry about the other questions. I will discuss. Anybody
So we
else
have
would
Sir,
to
like
can I
to?
write
ask a
like
question,
this
please?
in the
Sure, sure,
exam
sure.
or anywhere we want to write.
Wait. One by one. First, the name is Ashish Prasad, who asked me the
Yes,
question.
sir.
Yes, speak up.
Sir, when you want to write this question in our copy or somewhere, we have to write like this or some. There is predefined rule like how to write.
Like this only. How I have explained here.
Okay, sir.
Okay, fine. Yes, the next person who was asking some
Yes, sir.
question. Yeah, please.
I just want to ask, there is no difference between a string A or only one string A. There is a difference between them, or they are the same.
As if now they are same. If there will be some different in some other aspect, I will discuss.
Okay,
There
thank
is
you.
a little difference in them. Basically, what happens when we say that a string A, so it means at least this much it is accepting, and rest of the things also it can accept. But when I say only A, then we can say that it may not accept anything else. Only A. That means only single appearance of A. Okay. But as if now,
Okay,
don't
sir.
don't go into this much depth. By practicing some more questions, you will get these things automatically. Don't worry. Anybody else who is having any other question? Perfect. Since nobody has any doubt, so let's move on further. Okay. Now, in spite of going to more of the questions, now it's time to discuss that what is the difference between two different types of FAs. If you remember, I told you that there are two different types of FAs, right? There is a deterministic finite automata, and there is a non deterministic finite automata. You remember I told you this thing, that there are two different types of finite automatas. One is deterministic finite automata, one is non-deterministic finite automata. All right, now it's time to understand that what is the difference between these two types of machines. All right, although later on I will give you a list of differences, list of at least 6 to 7 differences, okay, but as if now you should understand only and only one thing. When you are designing automata, you should understand only and only one thing, that is the base difference. Rest of the difference you can write on your own. I will tell you how to write those things later on, okay, but what is the difference, core difference? Let's understand that. For a deterministic automata or deterministic finite automata, there must be, not should be, there must be exactly one path from each state with respect to each and every input symbol, okay. And for non-deterministic automata, there is no such restrictions. There is no such restriction. Okay, that means we may not draw, or let's keep it like this, there is no such restriction. You can understand easily, simple thing, okay. For deterministic finite automata, there must be exactly one path from each state with respect to each and every input symbol. But with non-deterministic finite automata, there is no such restriction. If we want, we can leave some paths. If we want, we can create some duplicate paths also, okay. Now let me explain this difference little bit more. For example, let's consider the previous question only, okay. Let us consider the previous question itself. So what was the previous question, where sigma was a, okay, and the string what we have to accept is a. This was the previous question, right? Now how to create a DFA for this and how to create an NFA for this. So let's understand. DFA for this particular one, DFA and NFA will remain same. The reason being because we have got only one input symbol, which is A. Similarly, we will create NFA. Okay, fine. So no, it will not be same. Now try to understand one thing. Now let me tell you what is the difference. What is the difference in DFA and NFA? Okay. So sigma is A for sure. String we have to accept is A for sure. Okay. Now from Q0 we have a path for A. We have two states, right? Q0 and Q1. How many symbols are there? Only one symbol, A. So from Q0, now we are talking about this diagram. I'm talking with respect to this diagram, okay. I hope everybody is quite attentive, and Eager to learn the things, right?
Yes, sir.
Be curious. So from Q0, do we have a path for A? Yes or no?
Yes, sir. We have a path
Yes,
for.
sir, to Q1.
Of course, yes, we have.
Okay.
From Q0, there is a path going to Q1. So from Q0, there is a path available. And there is no input symbol, so we have to check only for the A. Okay. But from Q1, have we created a path
No,
No,
sir,
sir.
No.
because Q1 is
with
the
respect to
final
A?
state.
No, we haven't created a path with respect to A, right? So there is no path. So this no path concept may work in NFA, but it does not work in DFA. So this is wrong DFA. Why it is wrong? Because from Q1 you haven't created a path for A. So if question is asking you to create, that's what the reason I have written here only FA, finite automata only. I have not written DFA. Okay. So if I might have written DFA, if this question might have been like this, design a DFA for the language which contains a string A. Okay, in that case you have to make sure that from Q0 there has to be a path with respect to A. From Q1 also there has to be a path with respect to A. Clear?
Sir, how we create a path from Q1?
Yes. How we will create that we will learn during the lecture, either today, tomorrow, or in the further
Sir,
lectures
sir,
that we will discuss.
sir, in that case, Q1 is the final state, right?
In every case, either in NFA, DFA, see, try to understand whether it is DFA, NFA, or on these things, final state is not going to change. Final state will be the final state if it is double circled. That's it.
Okay, sir.
If it is double circled, then it is final state. Even from Q1, see, first of all, try to understand one thing very clearly. A Q1, if Q1 is a final state, okay, it never means that from Q1 we may not go to any other state. It never means.
Okay,
Do
sir. I
not
got that.
create any such restriction. I'm saying this to everyone because it's a common question and it used to be the common myth when people are learning automata and creating automata. They think once we have reached to the final state, now automata will be ending up. Now it should end, but it's not like that. Automata never ends when it has reached to the final state. Automata ends only when the string what is given to you, that is finished. You read the symbol one by one, one by one, one by one, and whatever the string given to you, if the symbols in that string has been ended up, then only you can end the automata. But once you have reached to the final state, it never means that now your automata transition is ended up. Transition stops only when string ends up. If string is available, then you have to carry on your transition. Is this clear to everyone? I need a loud yes sir if it is clear.
Sir, how will string
Just
end?
sir, please, sir, just
Yes, ask your
can
question.
you can you please just re-explain the FA because I was having a internet connection error and I didn't hear what did you say about the FA.
So which part you want me to explain again?
The previous, the FA.
The difference between DFA and FA.
Yeah, sir, please.
Yeah, so basically for DFA we have to make sure that whatever the states available in the diagram, okay, from each and every state there must be a path with respect to each and every input symbol. So for example, the diagram which we have created, in this how many input symbols are there? Only one input symbol, which is A. Sigma, the length of sigma is only A. All right. Now the diagram which we have created, in this diagram we had a path from Q0 to A. Is it available? Yes, it is available. You can see from Q0 if we pass A we will go to Q1. Okay. But From Q1, is there a path? Answer is yes or no.
From Q1, no, there is no.
There is no path. That means this can be NFA, but this cannot be DFA because DFA has to follow this restriction.
Okay, okay, sir. Thank
Clear?
you.
Okay, fine.
Yeah, yeah, clear.
Anybody else is having any more questions? Somebody send some message. Can anyone tell me FA is a type of tuple or types of automata? Muhammad Asif Raja. Why anyone else will tell you? You have to ask your questions directly to me. Why you are asking to your classmates? Unmute your mic and tell me what is your doubt. You're asking, can anyone tell me FA is the type of tuple or types of automata? FA is the type of automata. In fact, not FA is the type of automata. DFA and fine, you can say FA is the type of automata, and in that base type, further two more types are there: DFA and NFA. So FA is not a tuple. FA is a automata. Tuples are these five: sigma, Q0, Q, F, and delta. FA is not a tuple. Daniel is saying, so can we say NFA for previous example? Yes, of course. Previous example was NFA, not a DFA. Okay. So now, although we have 6 more minutes, I want to teach further. But as I told you that in last 5 minutes, I will repeat the content. I will try to summarize the content of the previous class. So before leaving the class, everybody please drop your enrollment numbers in the chat box so that I can take it to the so that I can take it for the attendance. Drop your enrollment numbers. The people who want to listen the last lecture, who have missed the last lecture, okay, they stay with the class. I'm repeating the summary of last lecture now.
Sir,
Haji.
sir, as you say, like our automata ends when there is no input. So sigma,
No. Wait. I did not say when there is no input. I
no
said
strings
when you have ended up with input.
means ended with.
Do you understand Hindi?
Yes, sir.
ओके मैंने ऐसा नहीं बोला कि इनपुट नहीं है, मैंने बोला इनपुट तो है, लेकिन जब इनपुट पढ़ते पढ़ते आपका इनपुट खत्म हो गया. फॉर एग्जांपल, मैं आपको एग्जांपल से बताता हूँ. इफ यू हैव दिस डबल ए, लेट्स से 4 A's आते हैं, ओके, और 5 A's आते हैं. नाउ इज इट द केस दैट देयर इज नो इनपुट? नो, देयर इज द इनपुट. इनपुट तो है यहाँ पर, बट आपने पहला सिंबल पढ़ा, अभी इनपुट खत्म हो गया क्या? नहीं, बिकॉज वी हैव 4 अदर A's to read. तब आपने दूसरा A पढ़ा, you read the second A. Is that input finished? Still no. So you have to read the third A, similarly the fourth A, the fifth A. Now, have you finished reading input? Yes, because there is no other symbol. So now you have to stop the automata.
Sir, the other machine, sir. So A is the same. So 5 times will be this will be repeated. Okay, sir.
Now, how to repeat it 5 times or how to do that, that is the matter of further discussion. वो हम आगे समझेंगे lectures में कि उसको 5 बार repeat करना है, या अब 5 को अभी ये 50 A हो तो कि 50 बार थोड़ी ना automata बनाएंगे, तो वो कैसे करना है that I will tell you. मैं बताऊंगा आपको next lectures में.
Okay, sir.
Okay.
Sir, please.
Yeah. So
when are you going to upload the lectures, the recorded lectures?
I will send you the PPTs by today itself, and I guess I will upload the lectures by today also.
Okay, thank you, sir.
On the YouTube channel, right? So let me now start the previous class. I hope everybody please make sure everybody to drop your enrollment numbers without dropping your enrollment numbers, don't leave the class, otherwise your attendance will not be possible. Okay, and those people who want to take a brush for the previous class, the first class, stay here. I'm taking you. Okay, now why we are studying this subject, that is what I have discussed. Okay, so now let me tell you in a summary, in a nutshell. You must be aware about C language, right? Now may I please have a yes sir from all those people who are still taking the lecture?
Sir.
Yes, sir.
Yes, sir.
Yes, sir.
Fine, perfect. So these are the people who left yesterday's
Sir,
class.
we are enjoying class.
Okay, fine.
Definitely.
That's good. That's good. Now let's start doing this. So let us say you are writing a program for C language, a C language program you are writing. C, I'm taking you just for the example because you are aware with it. This can be any of the language, Java, .NET, whatever the etc language you have. Okay. Now what happens? You press the Alt F9 or Control F9 or whatever the command for the purpose of compilation. All right. After that, compiler checks what compiler do. Compiler checks for the errors, and it finds you out if errors are available. Then it reports the error. If there is no error, in that case it compiles successfully or it execute successfully, right? Now, have somebody ever thought that how compiler finds out the error? For example, if I have written printf like this, automata, if I have written it like this, okay, so is this statement correct or not according to C language syntax?
No.
Correct, sir.
Correct, sir.
Not correct.
This is
Not correct, sir.
what is the problem in this statement?
Sir, printf is F is capital.
Okay, consider it as a small. So is it correct or not?
Correct.
Correct, sir.
Correct. Okay, so it is correct. Fine. But if I have written like this,
No, sir, it's not correct.
is it correct or not?
Not correct,
No,
sir.
not
Not
correct,
correct.
sir.
So how compiler will find out whether it how compiler do this process, that how it checks that whether a statement is correct or not?
Taking line by line. Compiler.
No, line by line is not for the compiler. In fact, it is character by character. Okay, so let me tell you what it do. Basically, it has a pattern inside itself. There is a fixed pattern, okay, which is fed inside the compiler, which is fed inside the compiler for each and every statement what you are writing in a program. For example, the pattern can be something like this, that there is a fixed pattern written inside the compiler, that on the first statement, on the first character, you are supposed to have P, then you are supposed to have R, then you are supposed to have I, then you are supposed to have this, then you are supposed to have this, then small f, and then this symbol, and then this symbol, and then what you are supposed to have, either A to Z or A to Z or anything else also. All right. Similarly, for this thing also, A to Z, A to Z, or 0 to 9. Such so many things have been written over there. And then it is written that it is supposed to have double quotes, then it is supposed to have this particular one, and at last it is supposed to have this one. Now, how this pattern matching is done? The input what you have given, input does mean the string what you have written. Now this string is compared word by word with respect to this pattern. So for example, if compiler will compare this one, and it will find out that on the first character itself the pattern does not matches, okay, then what it will do, it will immediately produce one error and it will stop compiling this thing further. Okay, but if it does not find any problem, then it will continue to compile this. So this concept, when it is matching the things, this concept is said as pattern matching. This is called to be what? Pattern matching. And this pattern matching is the first step during compilation of a program. Although several steps are available, a lot of such steps are available, but out of that first step is this pattern matching. And throughout this whole subject, we have to understand that how compiler do this pattern matching. So this subject is TAFL, where T stands for theory of, A stands for, who is having these noises and all, please mute your call. Don't disturb others. Now, theory of automata. F stands for formal and L stands for languages. So the combinedly subject name is theory of automata and formal languages. So what is automata? Which we are studying right now. So automata is basically a machine, not a physical machine, but it's a virtual machine. Just wait for a second. Yeah, am I audible to everyone?
Yes, sir.
Screen must also be visible. Yeah, that's right. So automata is what? Automata is a machine. It do what? It do this pattern matching. For whom? For compiler. And how it do pattern matching, that's what we are studying right now. In today's lecture, we have studied this thing, and in further lectures also we will discuss this. So first we will cover this theory of automata, and after that I will discuss this formal languages. This is not the right time to discuss what is this formal language and how it works. So that's why I'm not going into that stuff. Okay, fine. So that's what this automata is all about. Now, is everybody clear? Somebody is having any more doubts? Then you can ask me. Be quick.
Yes, sir.
We have only 2 minutes. Yes, ask your doubt. If everybody is clear about this concept now, then say a yes, sir.
Yes, sir. It's clear.
Yes, sir.
Yes, sir.
Yes, sir.
If anybody is having any kind of doubt, now you can ask me with respect to this concept, the introductory class, what I've told in the last class. Fine. So I hope everybody must have given their enrollment numbers. Okay. So I'll mark your attendance based on that and see you in the next class. Okay. Fine. Let's leave this classroom.
Okay, sir.